All right, so hello and welcome everybody on this beautiful platform PW. This is your physics mentor Gaurav Tiwari. And today, my dear kids, we are going to have a discussion about 50 questions from the chapter of electrostatics and the chapter of current electricity, right? But before we do any of that, just let me know if I'm clearly audible and visible or not, right? So hello everybody. Just tell me if I'm clearly audible and clearly visible to you or not. Or if there is any problem, just let me know in the comment section. Hello everybody. All right, so this class is about the chapter of electrostatics and current electricity, right? So we'll be having a discussion of previous year questions from this chapter, right? And we will get a trend analysis from the, from these two chapters, right? Okay. So just tell me if I'm clearly audible and visible. Okay, so it's good. All right. Good evening, Ananya, good evening, Drago legend. All right. Okay, so let's start with this thing. Okay, so as always, you can attend the class with a notebook and a pen with your hand yourself. So I'll be showing you some questions. I'll be giving you time to solve it, right? And if you can solve it, it's good. Otherwise, I'll tell you the concept, and then whatever calculation is needed, I will tell you that as well, right? So let's start right away with the first part, which is electrostatics, right? From the electrostatics, generally 2 questions are asked, and from the current electricity, generally 2 to 3 questions are asked. So you can expect around 5 questions to 6 questions generally from these 2 topics, right? Okay, so let's have a look at the first question. The first question is talking about an electric dipole with a dipole moment 5 × 10⁻⁶ is aligned with the direction of uniform electric field of magnitude 4 × 10⁵ Newton per Coulomb. The dipole is then rotated through an angle of 60 degree with respect to the electric field. The change in the potential energy of the dipole is. So what will be the change of the dipole? Dipole is placed in an electric field at some angle, and now we are rotating it by some other angle. So what will be the change in the potential energy of the dipole, right? What will be the change in the potential energy of the dipole? My dear kids, if you know how to solve it, you can definitely move ahead and try to solve it in the comment section, right? For those kids who don't know how to solve this particular question, I'll be giving you the concept, right? So let's just look at the data. This question was asked in the Neet 2025, right? So again, a very important type of question this is. You will find many questions from the same idea of the dipole, right? So again, if you can solve it, your timer is going on, right? You can continue and talk about the solution part of it. But my dear kids, if you cannot, I will tell you the solution. My dear kids, if you have a dipole with dipole moment P, and it is placed in the electric field E, right? It is rotated from an angle theta I to theta F. What happens? Some work is done in this process, and due to that work done, whatever work you have done is stored in the system in a potential energy, because electric field is a conservative field, right? Electric field is a conservative field. It is a conservative field. So whatever work is done is stored in the form of potential energy, right? Okay, so how much change of potential energy you are going to see? So we can say that PE cos theta F minus theta I. I hope the idea is very clear, right? So, oh no, not. We can write it in this format. PE cos theta F minus cos theta I. I hope this is good, right? So we can get we can simply move on with this particular format. This is the change of potential energy. So you have a dipole with a dipole moment P. It is placed in the electric field E. You are rotating it from this initial angle to another initial and another angle from the electric field. So this is how much change of potential energy you are going to observe, right? So my dear kids, apply that concept over here, and you can see what will be the change of potential energy, right? Talk about that. Very good. So Ananya is saying D, and all right. So let's see that. I guess your time is up, right? Your time is up, and let us see that what is the answer. All right. So this time it didn't pick up, but no problem, right? So here you see that. Okay, here you see the concept, I believe, is clear with everybody. So from here you can see that initial angle is 0, then you are rotating it by an angle of 60 degree. So the change of potential energy or the amount of work done will be PE cos theta I minus cos theta F. So you see that the dipole moment is given, electric field is given, and cos theta I, cos 0 is 1, right? Cos 0 is 1, and cos theta F, cos 60 degree is half. So 1 minus half is half. So just multiply that and you will have an answer, 1 joule. Let's move on, talk about the next numerical. This was also asked in the year 2025, right? This was also asked in the year 2025. Have a look at this question and try to solve it as well. The question is saying that we have two identical charged conducting sphere, right? 2025 a question hai, right? So we have two identical charged sphere, A and B. They have their center separated by a certain distance. We have two charged sphere, right? A and B. They have their center separated by a certain distance. Charge on each sphere is Q. So charge on this one is Q, charge on the second one is also Q, right? And they are experiencing a force of repulsion. The force of repulsion between them is F. The force of repulsion between them is F, okay? All right. So right now when the charge on these is Q and Q, the force of repulsion between them is F, okay? All right. And they are placed at a certain distance. So imagine they are placed at a distance R, okay? Now, charge on each sphere is Q, okay. So, a third identical sphere, a third identical uncharged conducting sphere is brought in contact with the sphere A first, then it is placed in the contact with B, right? So, it is placed in the contact with the sphere A first, then with B, right? So, you are taking another uncharged sphere, right? This is uncharged sphere, identical. The third sphere is also identical to these two. So, you are keeping it in contact with the first one, then you will move it away and then you keep it in the contact with the second sphere. Now it has some net charge, okay? Now this sphere has some net charge, okay? Now the question is, it is finally removed from both. New force of repulsion between the same sphere A and B will be. So what will be the new force of repulsion? This is something you have to answer. My dear kids, again a very good question you have, right? Think about it, a very conceptual question you have, right? So you have your time running up right now. You can answer in the comment section. Those who can solve it can answer in the comment section, but those who cannot, I will explain the concept in the next page, right? So let us understand that. My dear kids, if two spheres are identical and conducting, so this one has charge Q, right? And let us say that right next to this charged sphere, if I put another conducting but uncharged sphere of same radius, so what will happen? We can say that if I put another uncharged conducting sphere of same radius, so what will happen? The charges will transfer from this one to this one, right? And since they are identical, at equilibrium, the amount of charge will be equal on both of them, right? So whatever charge we have, it will be divided in half amount, right? So total charge was Q, half of that is Q by 2. So at equilibrium, this one will have Q by 2 and this one will also have Q by 2. So when you separate them, so we can say that after separating, this one will have Q by 2 and this one will have Q by 2. Now understand that, first of all, this is the third sphere. You keep this third sphere, which also has the same radius, in contact with this one, right? And then you remove it. And after removing it, you put it in the contact with the second one. Think about it. Initially, it was uncharged, right? It has the charge 0. It has the charge Q. When you put them in contact, the charge will be half, right? So after contact with A, the new charge is Q by 2 and Q by 2 after contact with A, right? Because they are identical, right? And the charge will equally distribute. Now you remove it from A, okay? And now you put it in contact with B, right? So now what is happening? Again, they are also identical. Whatever total charge this system has, that will distribute half, right? So this one is taking Q by 2. This one is taking Q. So what is the total charge in the system? Q plus Q by 2, right? And this total charge will be divided half in both of them. So it is divided half in both of them. So it is Q by 2 plus Q. It is 3Q by 2. 3Q by 2 upon 2 is 3Q by 4. All right. So at equilibrium, once you put this one in contact with B, so this one also has a charge 3Q by 4. And the second one also has a charge 3Q by 4 at equilibrium, right? Now you are removing the third body from here, right? Now you are removing the charge particle C from here, right? So effectively what is happening? Particle A has a remaining charge Q by 2 and particle B has a charge 3Q by 4. And now you have to find out what will be the net force. You see that this is the net body, right? After touching it with the third body, this one has charge Q by 2 and this one has charge 3Q by 4. What will be the new force? We can say that the new force will be K times Q1 Q2 by R square. So Q by 2 and 3Q by 4 upon R square. My dear kids, previously when they had the charge Q and Q, they were placed at a distance R. The force was K Q1 Q2, which is q square by r square, right? This was the initial force and this is the new force. So we can say that here if you multiply that, k into 1 upon 2 and 3 by 4, right? And over here this q and q will become q square upon r square. So look at that part, right? Look at that part, kq square by r square. This is the initial force. So you see that this expression remains there, 3 by 8, and this is the original force, right? So the new force is 3/8 time of original force. I hope that is very, very clear, right? So Ananya is answering, very good. Rahul is answering, okay. Ayushi is also answering, very nice, right? So I hope the idea is very, very clear. The answer is B, right? And let us see that how many of you have given the correct answer. So you see that Ananya has given the correct answer, right? First of all, and let's say that the other kid has done a slight mistake maybe. I hope it is good now, right? And you know how to solve it. Rahul, clear hai? Okay. All right. Let's move on and talk about the next question. Okay. Right. So now the next question is saying that it is also asked in the NEET 2024. Right. It was also asked in the NEET 2024. My dear kid, have a look into this part. A metal cube of side 5 centimeter is charged with a 6 microcoulomb charge. The surface charge density of the cube is going to be. So what will be the surface charge density of the cube? What will be the surface charge density of the cube? So think about it and try to answer it, right? Think about it and try to answer it, okay? You have a minute to think about it, right? So your time is going on right now, right? And now for those kids who can solve it, they can directly go ahead and solve it. For those who cannot, I will tell you how to solve this particular question. So what is the surface charge density? We can say that whatever available charge we have to divide by the total available area, right? We have to divide with the total available area, right? So that will give us the surface charge density. That will give us the surface charge density. Yes or no? Right? Okay. So basically, we have a cube of side 5 centimeter. So what is a side? We can say 5 10 to the power minus 2 meter, right? One side is 5 10 to the power minus 2 meter. Now you think about it. This cube has how many sides? 6 sides. This particular side is 5 centimeter. That is 5 into 10 to the power minus 2 meters, right? So think about it. What will be the surface area of one side? We can say surface area of one side will be a square of this, right? 5 into 10 to the power minus 2 is squared, right? And we have 6 of these sides. So what will be the total area of cube? Total area of cube A is 6 times of this whole thing, which is 5 into 10 to the power minus 2 is squared, right? I hope that is very, very clear. This is the total available area that we have. Once we know the total area, what is the total charge? 6 microcoulomb. It is 6 into 10 to the power minus 6 coulomb, right? This is the charge. This is the area. Divided by that, you will get the answer, right? Divided by the whole thing, you will get the answer. I hope the idea is very, very clear, right? Okay. So let's move on and talk about the next idea. Okay. Let's move on and talk about the next idea. So here the option D was correct, right? Here the option D was also correct and Ayushi was correct in this one, right? Here the option D was correct and Ayushi was giving the correct answer. So you see that area of one face is this 0.05 ka square. This is area of one face. You multiply that by 6. This is the total available area, which is 0.015, right? And this was the available charge, 6 into 10 to the power minus 6. So what you have done is divide the charge by the total area of the total surface area of the cube, right? Once you do that, 4 into 10 to the power minus 4 centimeter square is the answer. This is the surface charge density. Coulomb per meter square is the answer. Sorry, coulomb per meter square is the answer. So that is the surface charge density. All right. So now let's move on and talk about another numerical. So it is also asked in the NEET 2024, right? Again a numerical from NEET 2024. Read it. Okay. ठीक है बेटा अनन्या, फोकस करेंगे. बहुत बढ़िया बेटा, बहुत बढ़िया, राइट? So instead of putting up the answer, try to put the option only, beta Ananya. ठीक है? The value of electric potential at a distance 9 centimeter from the point charge, this much from the point charge, right? 4 into 10 to the power minus c coulomb is given as, right? So what will be the value of electric potential at a distance of 9 centimeter from the point charge? This is something you have to answer, right? What will be the value of electric potential? 2024 में आया हुआ सवाल है. This question was asked in year 2024, right? So what is the value of electric potential? KQ by R, right? This was the only concept, right? Direct formula based question. K is 1 upon 4 pi epsilon naught, right? And if you can solve it, definitely it's going to be a very positive sign for me and you as well, because a formula based question is something that I expect that you guys can do at this point of time, right? All right. So keep on moving and keep on trying. What will the value of this particular thing? Value of electric potential at a distance of 9 centimeter from the point charge is this, right? From the point charge is this. What will be the final answer? Okay. KQ by R, right? So we are finding the value at a distance R, 9 centimeters. So convert that into meter, 0.09 meters, right? What is the value of point charge Q? It is given 4 10 to the power minus 7. What is the value of K? Which is 1 upon 4 pi epsilon naught, 9 10 to the power 9. Everything is given, just multiply it and you should get an answer, right? Okay. All right, so let's see how many of you are actually correct. So just multiply that and option D should be correct answer. So here the kids are wrong. But anyways, if you have not multiplied it correctly, right? Many kids might have multiplied it directly, right? So they might not be taking, this is 9 centimeter. So you have to convert into 9 10 to the power minus 2 meters, right? Okay, so that is something you have to take care of, right? And once you do take care of that part, Q is also given, R is also given, and 1 upon 4 pi epsilon naught is also given. Just multiply all of those things, right? And divide it by R, right? So you will get 4 into the power minus 4, 4 into the power 4, sorry, volts, right? So that is the answer, which is the option D, okay? So some silly mistake you might have done. So here what is happening? Here a thin spherical shell is charged by some source, right? So somewhat problem has happened in the typing part, but no problem. I will read it for you. So this was also asked in the year 2024. In this question, what is happening? A thin spherical shell we have a thin spherical shell, right? And now what is happening? We have charged it, right? We have charged this thin spherical shell. We have a shell, not a solid body. We have a thin spherical shell, right? So the potential difference between 2 points C and P. C is the center of the shell. P is the point on the circumference of the shell. It is shown that 1 upon 4 pi epsilon naught is 9 into 10 to the power 9. 1 upon 4 pi epsilon naught is 9 into 10 raised to the power 9. Okay. All right. So now you have to tell that. Okay. Now you have to tell that. Okay. In this particular question, we have a thin spherical shell which is charged by that. What will be the potential difference between these 2 points? What will be the potential difference between these 2 points? Think about it, right? No problem, Ananya beta, no problem. I hope you can solve this particular question, right? So I will give you 90 seconds to think about it, okay? A minute and a half to think about this question, right? For a uniform charge spherical shell, what will be the potential difference between these 2 points? What will be the potential difference between these 2 points? Okay, you need to think about, for a spherical shell, we have the same potential, KQ by R is the value of potential, and that is constant across this point, and it changes, you know, like this after the point P, right? Okay, so we know that the potential across a shell is KQ by R. R is the radius, R is not the distance from the center, right? So we have the same potential from the center till this point, okay? So if we have the same potential from the center to the point P, will we have any potential difference? Think about it, right? We know that for any point inside or onto the surface, for the values of distance from the center, if it is R, for R less than or equal to the radius of the sphere, for the R less than or equal to the radius of the sphere, potential is KQ by R, we know that. So the variation of potential is 0, right? So potential is flat in this particular portion, and then it reduces, right? And then it reduces like this, okay? So what is really happening from here to here? Potential is same. So what will be the difference of potential between C and P? Think about it. What will be the potential? Very good, very good, very good. Ayushi, very good, Ayushi, very good, Ananya, right? Think about it, it is 0, right? It is going to be 0. Okay, let's move on and talk about the next idea. It is going to be 0. Okay, so let's see. It is 0. Okay, so everybody is correct, right? And let's move on and talk about the next question. So read it. Okay, this is from the Neet 2023, right? Again, a very recent question. So we are getting an idea about what kind of questions are asked, right? So from electrostatics, directly see the question and tick it. This kind of question we have, or just simple solution it is there, right? So from the 12th grade topics, 11th grade topics we have already covered. From the 12th grade topics, you will find that we can from the 12th grade topics we are getting a much easier level of question paper, right? Okay, let's look at that. According to the Gauss's law of electrostatics, the electric flux through a closed surface depends on which of these things? Again, your time starts now, right? Okay. According to the Gauss's law of electrostatics, electric flux through a closed surface depends on which of these things? The area of the surface, the quantity of the charge enclosed by the surface, the shape of the surface, the volume of the closed surface. So on which of these things it depends? According to the Gauss's law of electrostatics, electric flux through a closed surface depends on which of these things? So with an example I have shown you, like this is the light bulb, right? And what actually decides the value of electric flux? We can say that by the Gauss's law, we imagine a closed surface around it. So imagine this light bulb is glowing, right? So in the main classes I have shown you this light bulb was glowing and all, and I have taken this enclosed surface around it, and I have shown you this, that the field lines coming out of it were not changing, right? Or you can say the field lines were dependent on the charge enclosed by the surface, right? It depends on the charge enclosed by the surface, right? So we can say that it depends on the quantity of charges enclosed by it. So option B is correct. Very good. Very good. Very good. Right? Very good, Ananya. Very good, Ayushi beta. So let's keep on moving and talk about the next part. Here is the next question, again from the Neet 2023. A charge Q is placed at the center of a cube. The flux coming out of any one of its faces will be. So if you have seen the one shot that I have created, a very small, a very precise one shot on electrostatics, there I have shown you all the possible cases for a cube. I have shown you that this is the cube, and if we have a charge particle here on the surface, here on the edge, here inside, and somewhere like you can say that, right? There are multiple places. We can also have a charge particle here on the edge, right? So in all those places, how much flux will be enclosed by the how much flux will be associated by the cube, and hence with one surface as well. So basically we have the charge Q placed at the center of the cube, right? So you know that the flux is going to be charge enclosed upon epsilon naught, but we don't want to know the flux with the entire cube. The flux coming out of any one of the faces, flux coming out of any one of the faces will be, right? Charge is given is in microcoulomb. Charge given Q is in microcoulomb. This is in microcoulomb, which is why we are multiplying with 10 to the power minus 6, right? Which is why we have 10 to the power minus 6 multiplied over here. Try to answer it over here, my dear kids. Right, try to answer it over here. So we can start this particular thing, right, over here, right? So what will be the charge coming out from one particular side? What will be the charge coming out from one side? Very good, Anya beta. Very good, Ayushi. Aryan, try to answer it. Okay. So what will be the value of flux coming out of it? So we can say that the flux coming out will be charge enclosed upon epsilon naught, and since we are only asking about what will be the flux from one side, so we have to divide it by 6. Okay. It's Q upon 6 epsilon naught into the power minus 6. So I hope the idea is clear that option D is going to be the correct option. Option D is going to be the correct option, right? So you see, very good. Ananya has given the correct answer, and also Manjulika has given the correct answer. Very nice. So let's move on and talk about the next idea. Right. The next question is from Neet 2021, Manipur. So the question is saying that a conducting sphere of radius r is charged. A conducting sphere of radius r is charged. Then the electric field at a distance r, it is more than the radius of circle, such that r is more than the radius of circle. From the center of the sphere would be, which of the following expression is correct? Right, it is rv upon r cube. Second is this is rv upon small r cube, capital RV, and this is what? This is v, right? This is capital R cube upon small r cube, right? R square v upon r cube, and this is v by r. So these are the 4 options. It might not be very clearly visible to you, so I have written it over here. So these are the options written over here, right? Okay, we are all right. I hope the idea is very, very clear. So this is square, right? All right, now it is correct. So these are the four options that you have, right? So these are the four options that you have over here. So first option is RV upon R cube, second option is R square V upon R cube, third is RV upon R square, and fourth option is V upon R, where V is the potential on the surface. What is V? V is the potential on the surface, right? So we have to talk about what will be the electric field over here. We have to talk about what will be the electric field over here at this point such that R is more than R, right, over here. Think about it and tell us what will be the final value. Think about it and what will be the final value. C. Very good. Very good, right? So C is actually the correct answer, because now you don't have to think much about it, because you know that V is equals to KQ by R, and you know that by replacing it correctly, you will find that E is equals to KQ by R square. So if you replace these things in it, you will automatically get E is equals to VR upon R square, which is the option number C, right? Let's move on and talk about the next one. An electric dipole is placed at an angle of 30 degree with an electric field of intensity 2 into 10 to the power 5 Newton per coulomb, right? The electric field intensity is 2 into 10 to the power 5 Newton per coulomb. It experiences a torque of 4 Newton meter. It experiences a torque of 4 Newton meter. Calculate the magnitude of charge on the dipole. Calculate the magnitude of charge on the dipole. If the dipole length, if you are measuring the dipole length 2a, this entire 2a is given, right? The dipole length is given 2 centimeter, right? So these are all the values you have given with you, right? So an electric dipole is placed at an angle of 30 degree. Electric dipole is placed at an angle of 30 degree with the field intensity of this much. It experiences a torque of 4 Newton meter. We have to calculate the magnitude of charge on the dipole. We have to calculate the magnitude of charge on the dipole. Everything is given to you and we have to find the magnitude of charge. So option is 6, 4, 2 and 8 millicoulomb, right? So try to solve it and put the answer over here. Okay, try to solve it and put the answer over here. Everything is given. The electric dipole is placed at an angle of 30 degree in the field of intensity 2 into 10 to the power 5. The torque acting on it is 4 Newton meter and the value of the length of the dipole is 2 centimeter, right? So for that data, you have to figure out this part, right? You know that the torque acting on the dipole is, what is the concept? Torque is simply PE sine theta, right? The torque acting on the dipole is PE sine theta. Okay, this is going to be the simple concept. Torque is going to be PE sine theta. Right, electric field is given, theta is given. What will be the dipole moment? Dipole moment is charge into the distance of the length of the dipole, 2a, right? My dear kids, total length of the dipole is given, right? Not just the a is given, total length is given, 2a is given, so it is 2 centimeter. So charge on the dipole is something you have to figure out, right? Okay, and the length of the dipole is 2 centimeter, so 0.02. Right, so you see that in place of P, you can put 0.02 into Q, right? Electric field, you can put over here this value, and sine theta will be sine 30. Torque is given 4. Everything is given. Q is the only variable. You can figure out that part, right? Very good, Manjulika beta. Very good, Ananya. Right? Very good. Everybody is giving the correct answer, right? And option C, as many kids are giving, are absolutely correct, right? And let us see that. Okay, so Ananya is actually correct, no problem, right? So I hope the idea is very, very clear, right? So here we have it, just put the values and you will have your answer, right? Which is 2 millicoulomb. Now look at that. This was asked in NEET 2022. Again, a very recent question, right? So we are trying to get an idea about what kind of questions are asked, right? So look at this question. The angle between electric lines of force and the equipotential surface is. What is the angle between electric lines of force and equipotential surface? This is something you can answer in 30 seconds, right? So try to answer in 30 seconds. Okay. So try to answer over here in 30 seconds. For those kids who don't know, let me explain you the concept. Okay. While the kids are answering, let me explain you the concept. So what is the angle between electric line of force and equipotential surface? So over here we have it. This is let's say the equipotential surface, or just for an easier example, imagine that this is the equipotential surface. This surface is equipotential. That means this point and this point and this point and this point, all of them are at the same potential, which is why equipotential. Think about it. If we have electric field over here, electric field exists because of potential difference between these 2 points will not be at the same potential because we have electric field in this line, right? These 2 points have the potential difference, which is why we have the electric field between them. Yes or no? My dear kids, what is really happening? Think about it. If the electric field is making an angle with the surface, equipotential surface, let's say that if this is how the electric field is, right? Think about it. In this situation, a component of electric field will be along the plane as well, right? If the electric field is at an angle from the equipotential surface, in that situation, the electric field will also have a component along the surface itself, and in that situation, whenever you have electric field along the points along the electric field, all the points are not at the same potential, or the points are at the potential difference, which is why we have the electric field, right? Electric field exists because of potential difference between 2 points from higher potential to lower potential, right? Now look at that. This electric field you observe, these points must not be at the same potential. All these points are at different potentials. Yes or no? And since they are all at different potential, you can say that this surface will not remain equipotential anymore. So we can say that this component cannot exist, and that is only possible when the electric field is perpendicular to the surface, right? So this is not a possible direction for the electric field. So we can say that electric field has to remain perpendicular to the equipotential surface. Electric field has to remain perpendicular to the equipotential surface. So option C is the correct option. Option C is the correct option. And here we can say that Ayushi is correct, Manjulika is correct, and Ananya is also correct, right? I hope the idea is very clear. Let's move on and talk about the next concept, right? So this is again asked in the Neet 2022 paper, right? So the question is, 2 hollow conducting sphere of radii R1 and R2 have equal charges. What will be the potential, right? If we have 2 hollow conducting sphere of radii R1 and R2, 2 hollow conducting sphere of radii R1 and R2, right? They have equal charges. The potential would be, what will be the more on bigger sphere, more on smaller sphere, equal on both sphere, depend on the material property of the sphere. Think about it and try to answer it. Again, you should not take more than 30 seconds to answer this particular question. 30 seconds mein answer karna hai. You have to answer this question in 30 seconds. We have 2 hollow conducting sphere of radii R1 and R2. They have equal charges. It is given R1 is more than R2. It is given R1 is many times more than R2, right? It is given over here, right? The potential would be higher in one, lower in second. What will be the case? You have to answer, right? So think about it. The concept is very same or similar over here. The potential for the case of at a distance less than or equal to the radius, for this situation the potential is kq by r, right? Kq by r. So you see that potential is inversely related to the radius of the conducting sphere, right? Or shell, whatever it is. So potential and the radii, they are inversely related. So the bigger sphere will have lesser potential throughout. Yes or no? Bigger sphere will have lesser potential. More the radius, lesser will be the potential. So we can say that R1 is more, bigger the radius, lesser potential. So V1 will be lesser than V2. Yes or no? So we can say that it is more on the smaller sphere. Potential is going to be more on the smaller sphere, right? Very good, Ananya. B is correct. Yes, Chandu beta, good evening. Right? Very good, Ayushi. B is correct. Very good, Manjulika beta. B is correct, right? So B is the correct answer, right? And everybody gave the correct answer, right? My fastest answer was given by Manjulika this time, and then Ayushi, and then Ananya. So Ananya is lagging behind now for some reason. You have to be faster, right? So here it is. Neet 2021 mein again this question was asked, right? The question is this: polar molecules are the molecules having a permanent electric dipole moment, having zero electric dipole moment, acquire a dipole moment only in the presence of electric field due to the displacement of charges, acquire a dipole moment only when magnetic field is absent, right? So what will be the situation? This is something you have to answer, right? What will be the situation? This is something you have to answer, right? Again, a very simple, straightforward question. You should be able to answer it in the 30 seconds window, right? The polar molecules are the molecules. My dear kids, what is a polar molecule? Molecules where the atoms, for example, water, or you can think of like HCl, right? Okay. So this is the covalent bond. The electrons are shared in the covalent bonds. But chlorine is a very highly electronegative substance, right? So what really happens is these electrons are attracted towards the chlorine and they are shifted towards the chlorine, because of which electrons are closer to chlorine in the bond than hydrogen, because of which a partial negative charge is created over here and partial positive is created on over the hydrogen. Now here you see that in HCl, you can see that this molecule is a polar molecule. One side is permanently positive and one side is permanently negative, right? You are not providing it, like if there is no electric field, then also chlorine will do what it does, right? It will attract the electron. So you don't need an external field to polarize it. So these particular molecules have a permanent electric dipole moment. These molecules have a permanent electric dipole moment. I hope it is making sense, right? So here the option A is the correct option. Here the option A is the correct option. Very good, Brother Chandu. Very good, Ananya. Right? So let's have a look at that. Right. So here Ayushi was correct, but I don't know why the Chandus and Ananya, answer was not taken. But anyways, in the NEET 2021, this question was asked. It is saying that the two charged particles, leave it. So this question is solve this question, right? So 27 drops of same size are charged at 220 volt each. 27 drops of same size. 27 drops of same size are charged at 220 volt each. Okay, so each of them is charged at 220 volt. Right? They combine to form a bigger drop. So they combine, these 27 drops combine to form a bigger drop. Calculate the potential of the bigger drop. So they are all charged at 220 volt. They combine to form a bigger drop. What will be the potential of the bigger drop? This is something you have to answer. Again, a very, very good question. Right? Again, a very good question you will have over here. Right? Try to solve it, and this question will take some time from you. So take about 90 seconds to solve this particular question. Right? Take about 90 seconds to solve this particular question. Think about it. Right? You have 27 droplets. Let's say that each droplet has a radius r, and when you join them, the new bigger droplet has a radius capital R, right? Okay. So think about it. So here we have 27 droplet. What will not change? We can say the volume will not change. Yes or no? What will not change? The total volume of 27 droplet and the total volume of one bigger droplet will be same. So over here we can say that 27 times of 4 by 3 pi small r cube. This is the volume of a single small droplet. This one, that is same as 4 by 3 times 4 by 3 pi capital R cube, right? So we have to cancel these two parts, right? So 27 into R cube means 3R cube, and that is equals to R cube, right? Okay. So over here we can say that R is equals to 3 times R. All right. R is equals to 3 times R. I hope the idea is very, very clear. Okay. I hope the idea is very, very clear. Okay. And if you have any question or confusion, you can definitely ask me. Okay. R is equals to 3R. This is the idea, right? So for the bigger spherical droplet will have a radius 3 times than any of the smaller ones. Now you can talk about the potential. The potential of individual things is 220 volts. Every one of these ones have a potential of 220 volts. They are charged at 220 volt because. Now think about it. So V is equals to potential of these small things is kq by small r, and that is 220 volt, right? We have to talk about the potential of the bigger droplet. So what will be the potential of bigger droplet? Kq by, what will be the potential of bigger droplet? V dash k times net charge upon bigger radius. My dear kids, each of these small droplets have a charge, let's say that q, right? When you add them all together, the net charge over here will also add up. Yes or no? So net charge, because 27 droplets are added, so net charge will be 27 times small q, right? All right. and R, capital R, the radius over here is 3 times the radius of individual particles, 3 into R, yes or no? So this is 9, right? So 9 times kq by R. Kq by R is the old, or you can say the potential of individual small droplet, which is 220. So 9 into 220 will be the answer. I hope the idea is very, very clear, right? Is there any problem in this part? 9 into 220 will be the final answer. 9 into 20 will be the final answer, which is 9 to 18, 1800, and then 18, 1980, right? So option A will be the correct option, right? 1980, A will be the correct option. Very good, Chandu, right? So option A will be the correct option. Okay, so Ananya and Manjulika were able to solve it. Very nice. Let's keep on moving and talk about the next numerical, right? Okay, so this numerical is talking about, this was asked in the year 2020. The question is saying that we have a short electric dipole and it has a dipole moment of 16 10 to the power minus 9 centimeter. The short electric dipole has a dipole moment of 16 10 to the power minus 9, 16 10 to the power minus 16 10 to the power 9 centimeter coulomb meter, right? The dipole moment is given for this dipole, which is 16 10 to the power 9 coulomb meter, right? Okay, the electric potential due to the dipole at a distance of 0.5 meter from the center of the dipole situated on a line making an angle 60 degree with the dipole is. So there is a dipole, right? So from this line there is a point at a distance 0.5 meters away and making an angle of 60 degree, right? What will be the potential over here, right? This is the point P. So we have to talk about what will be the electric potential at this particular point. For this dipole moment is given. We have to talk about what will be the electric potential at this point, right? So you have to talk about that. So direct formula is there, right? I believe 45 seconds will be enough for this particular question. What is the formula for electric potential due to electric dipole? What is the formula for electric potential due to the electric dipole, right? The distance is given, okay, it is 0.6. It is not written very clearly, so this is given 0.6, right? Okay, think about it, right? 1 upon 4 pi epsilon naught, as you know, is 9 to the power 9, right? So you can directly go ahead and solve it, right? Very easy. Now, if you don't know the formula, the electric potential because of a dipole is Kp cos theta over r square. Yes or no? Kp cos theta over r square, right? So think about it. The value of K is 1 upon 4 pi epsilon naught, which is 9 10 to the power 9. So K over here is 9 into 10 to the power 9. Okay. P over here is the value of dipole moment, which is 16 10 to the power 9. 16 10 to the power 9. Cos theta over here is cos 60, which is 1 upon 2, and r over here is 0.6. So 0.6 square is 0.36. All right. So everything is given. You just have to calculate, and that's all, right? Okay. Ananya is saying A. Ayush is saying A. Okay. Very good. Chandu is saying 200 volts, which is option A. Very good. Manjulika is saying D. All right. So let's see how many of you are actually correct. Okay. All right. Yes. So every kid that is giving the option A is actually correct, right? So let's move on and talk about the next one. The question is saying in a certain region of space with volume 0.2 meter cube. So there is a region of space, and that space has a volume of 0.2 meter cube. The electric potential is found to be 5 volt throughout. The electric potential found to be electric potential, not electric field. Electric potential found to be 5 volt throughout. So everywhere the potential is 5 volt and the volume occupied in this space is 0.2 meter cube. The magnitude of electric field in this region is going to be. So what will be the magnitude of electric field in this region? A conceptual question, right? Anyone who knows a basic concept, right, should be able to solve it without even picking up the pen, right? It was asked in the Neet 2020. So the concept of equipotential surface, you see that the concept of equipotential surface is a very dear darling concept of Neet, right? They keep asking this particular question, right? And they keep asking questions from this concept. So you have to focus on the concept of equipotential surfaces, right? They are telling us in this volume everywhere the potential is 0.2 and that potential is 5 volt. You have to tell that what will be the magnitude of electric field in this region. Okay, again, very good beta. Ayush is saying A, Nima is saying Nima Fazal is saying A, Ananya is saying D. Okay, all right, so think about it. What creates the electric field, my dear kids? What creates? Think about it. You don't have to think about the relation between electric potential and electric field. Many kids are thinking about difference, many kids are thinking about the relation between electric potential and electric field because the electric potential is given, electric field is something they have to calculate. My dear kids, the electric field exists between 2 points when they are in different potential. Think about it. These are the 2 points, right? Right now, let's say imagine that this is a charge particle. The charge particle over here will not move from this point to this point, but as soon as you create a potential difference, you see that one point is higher, one point is lower, the charge particle will automatically move from one point to the other point, right? From the point of higher potential to a point of lower potential. Yes or no? The charge particle automatically moves because of potential difference. Now here, if we are saying A and B are at the same potential, right? Now think about it, the charge particle will not be able to move, right? Because there is no potential difference between 2 points. That means there will be no electric field, right? Yes or no? Electric field requires 2 points to have a different potential, and here you have seen everywhere the potential is 5 volt. As I said, potential is everywhere 5 volt, and if potential is same, there is no potential difference, that is there is no electric field inside. So answer should be 0. Okay, I hope the idea is very, very clear. Yes, ASER 7, you can watch it for revision, no problem. This is even in fact best for you because every question is a previous year question, right? So try to solve this question now. It's again a Neet 2020 question, right? And just look at the question. A spherical conductor of radius 10 centimeter has a charge of 3.2 into 10 to the power minus 7 coulomb. A spherical conductor has a charge 3.2 into 10 to the power minus 7 coulomb. It is distributed uniformly. That is, the magnitude of electric field at a point 15 centimeter away from the sphere will be, right? The radius of the spherical conductor is 10 centimeter, my dear kids, right? And you have to tell that the magnitude of electric field at a point which is 15 centimeter away from the center, right? At this point P, you have to tell that what will be the magnitude of electric field at a distance 15 centimeter from the center of the sphere, right? These are the options. Again, a very simple question you have. For any point outside the charge sphere, this whole thing will behave like a point charge, right? So in the previous numerical, what was the option? Option D, right? Okay. All right. So think about it. Very simple numerical you have, right? So here you have it. Your time is running, okay, and your poll is also running. Okay, you can answer in the comment section. So here you have it. The spherical conductor has a radius 10 centimeter. You have to find the value of electric field. You have to find the value of electric field at a distance 15 centimeter away from it. So answer it. Simply kq by r square, right? The value of electric field over here will be kq by r square. For a point outside the charge sphere, this whole thing will behave like a point charge and it will be kq by r square. So kq over r square. Value of k is 9 10 to the power 9, 1 upon 4 pi epsilon naught. Value of charge is 3.2 into the power minus 7 coulomb. Q is also given, and distance is 15 centimeters. So 15 10 to the power minus 2 meters, yeah, 0.15 meters, right? Everything is given. The value of electric field will be calculated, right? Everything is given. The value of electric field can be calculated. Tell me, right? Everything is given. The value of electric field can be calculated. Okay. So over here, very good, right? So Chandu is giving the right answer, Ayushi is giving the right answer, Ananya is giving the right answer. Very good. All right, so let's continue to keep on moving in the forward direction, right? And let's talk about another numerical, right? So here we have it. This was asked in the year Neet 2019, right? So we are going backwards, right? and gradually we will look at, let's say, 5-10 questions more from electrostatics, few questions more from electrostatics, and then we will jump onto the current electricity questions, right? So at this time I will suggest that do not solve so many questions on circuit solving. Basic KCL KVL you can solve, but it is not the time to solve so many questions on circuit solving. You will see for yourself, it is not the only concept that they ask from the chapter, right? I will show you, but for now just look at this electrostatic question. 2 point charges A and B having the charge plus Q minus Q, they are placed at certain distance apart, right? This is plus Q, this is minus Q, right? They are placed certain distance apart, and force acting between them is F. So whatever force is acting between them, you call that F. If 25% of A is transferred to B, so 25% of A is transferred to B, 25% of charge of A is transferred to B, then what will be the net force? Think about it. Again, a very simple question, right? And you can solve it, right? A very simple question and you should be able to solve it, okay? So now think about it. If you remove 25% from that, 25% means 25% is 25 by 100 into Q, which is 1/4 of Q, right? Or Q by 4 simply. So you are taking Q by 4 from here and you are adding up on this side. So when you remove Q by 4, 25% is removed from this portion. So what is left? Q minus Q by 4, we have 3Q by 4, right? And what do we have over here? That plus Q by 4 is transferred to the second body. So minus Q plus Q by 4, that is added, right? So minus Q plus Q by 4 is minus 3Q by 4, right? So minus 3Q by 4. Now what will be the net force, right? So the net force will be K times Q1 Q2 by R square. R is same. Previously the value KQ square by R square, it was the original force F. Now the new force is K times 3 by 4Q into 3 by 4Q upon R square. So 3 by 4 square, which is 9 by 16 times previous force. I hope the idea is very, very clear, right? Very good beta, very good. Neema, Faisal, very good. Ayushi beta, very good. Chandu, very good. Skylar, okay. Very good, Ananya, okay. I hope the idea is very, very clear. 9 by 15 times of previous value. Option C should be the correct option. Okay. Option C is the correct option. Let's move on and talk about the next one. Right. It is again from the Neet 2019. The question is saying that a hollow metal sphere, conducting sphere, metal means conducting sphere, of radius r is uniformly charged. It is uniformly charged. Even if they are not writing that it is uniformly charged, we have to know that it is a metal sphere, so the charges will distribute uniformly. So it's a uniformly charged sphere. The electric field due to the sphere at the distance r from the center. The electric field due to the sphere at a distance r from the center is 0 as r increases for r less than r, decreases as r increases for r radius more than the radius of the sphere. Okay, so the first option is saying that electric field is 0 as r increases for any value of r less than r. Okay, that is the radius of this thing is capital R. For if the r is smaller than the capital R, radius of the sphere, we can say that the value of electric field is 0 in this region. Okay, it's a spherical shell. A hollow metal means a spherical shell. Okay, and it decreases as r increases for more than r values, more than radius. So in these region we are talking about, so if the radius, if the distance increases, we can say that the electric field decreases, right? We can say that reasonable torque, yes or no? It is saying the reasonable torque, isn't it? Right? Very good, Chandu, very good, right? And the second part is it is 0 as r increases for r less than r, and it increases as r increases for r more than r, beyond the sphere it increases. We can say which is wrong, because you know that in this region the potential is same, so there is no electric field from center to over here, right? There is no electric field inside, and at any point beyond that the electric field reduces with the inverse square law. So option A is actually the correct option, right? Read this question. Two parallel infinite line charges with linear charge density plus lambda and minus lambda coulomb per meter, they are placed at a distance of 2r in free space. what is the electric field midway between the two line charges? What will be the electric field midway? What will be the value of electric field over here? Right? What will the value of electric field over here? Think about it. We know that in case of a linear charge distribution at a distance r, right, the value of electric field at a distance r is 1 upon 2 pi epsilon naught lambda by r. 1 upon 2 pi epsilon naught lambda by r, right? You can also write it 2 times k. 1 upon 4 pi epsilon naught you write as k. So 1 upon 2 pi epsilon naught is 2 times k, right? Or you, if you don't remember that, you can multiply and divide by 2. So it will automatically 2 into k. 2k lambda upon r, right? So if the linear charge distribution has lambda, right, the density is lambda, then at a distance r away from it, the value is going to be 2k lambda by r. Yes or no? The value of electric field is going to be 2k lambda by r. So think about it. Because of this distribution, the value of electric field over here, you will imagine a unit test charge over here. The positive side will repel it and the negative side will attract it. So because of both of these things, the net electric field is adding up. So the net electric field is, because of this positive distribution, it is lambda upon 2 pi epsilon naught into r, and because of this negative distribution, it is also in the same direction. So lambda upon 2 pi epsilon naught into r. Is that clear? The whole separation was 2r. That means this is r and this is also r, right? So we can add this up and the whole value will come out to be lambda upon 2 pi epsilon naught r. That's it. Lambda upon 2 pi epsilon naught r. Oh, 2 will be removed because this 2 will come out like this, right? So lambda upon pi epsilon naught r, right? Which is option C. Which is option C. I hope the idea is very, very clear, right? Option C. Very good, Ananya. Very good, Ayushi beta. Very good, Chandu beta, right? So option C is the correct option. Let's move on and talk about the next question. It is asked in the year NEET 2018. So we are going backwards, right? The question is saying the electron falls from rest through a vertical distance h in a uniform and vertically upward directed electric field. This question is directly from the NCERT solved example, right? If you have read NCERT, in the NCERT itself, there is a solved example and we are, this question is picked from there, right? An electron is falling from rest. Electron is falling from rest. So initial velocity is 0. Through a vertical distance h, electron is falling through a vertical distance h, initial velocity of the electron is 0, in a uniform and vertically upward electric field. So the vertically upward electric field means this one is positive and this one is negative because field is from higher potential to the lower potential. This is how the electric field is, right? The direction of electric field is now reversed, right? Initially this was the direction. Then what is really happening? The direction of electric field is now reversed. So now the electric field is in the downward direction, okay, right? And now what is happening? Keeping its magnitude same. So electric field is still same, but the electric field direction has been reversed. So clearly this is higher potential and this is lower potential, okay, right? And now what is happening? Reversed, keeping its magnitude same, and now a proton is allowed to fall from rest. So now we are allowing a proton to fall from rest. This is electron and this is now a proton, right? Initial velocity of the proton is 0 through the same vertical distance h. So through the same vertical distance h, okay? The time of fall for the electron in comparison to the time of fall for proton will be, what will be the time of fall for the electron as compared to the time of fall for the proton, right? It will take more time, it will take less time, it will take less time, it will take more time. How many, what will be the ratio of the time basically? We have to talk about that particular part, right? We have to talk about that particular part, right? Okay. नहीं वरेंद्र ठीक है. तो यहाँ पर देखो क्या बात करने वाले, केवल 2 चैप्टर्स हैं, right? This is the first thing. So now again this is a long question. So I will tell you the concept, right? Entire solution मैं explain करूँगा तो बहुत time लगेगा. So I will tell you the concept behind it. My dear kids, what will decide the time of falling? We can say that first of all we have to look at what is the net force acting on it, right? Initially when we say that this is the electron, right? This is the electron we have. So what will decide the acceleration? We can say that the effect of gravity can be neglected because the mass of these things is so small. The effect of gravitational force we can neglect and we can assume that only electrostatic forces are there. Since it's a negative charge, electron is a negative charge, it will be attracted towards the positive side opposite to the electric field, right? And how much force is applied by the electric field on the electron? Force by the electric field on the electron will be E into E, right? E into Q, right? So the charge on the electron is a small e. Now, because of the force, the electron will be accelerated by acceleration, force upon mass of electron. Yes or no? And now the electron is accelerating with this force. You see that the electrostatic force is constant, mass is constant, so acceleration is constant. So electron is moving between the plates at a constant acceleration. When a particle is moving at a constant acceleration, it will travel that distance in a certain time, and we can find that time by equation of motion, right? Equation of motion for constant acceleration or uniform acceleration. So we can say that S equals to ut plus half at square. All right. The distance it is falling is equals to h, separation between the plates, right? Initial velocity is 0 because electron starts from 0, initial velocity is 0. Half at square, acceleration is the force E upon mass, right? And t square. So from here, the time of fall for the electron can be calculated. Same calculation we will do for the proton, and then we will take the ratio. That's all, right? Okay. Okay, just focus karo beta, right? So let's focus on the next numerical. NEET 2017 का सवाल है ये, right? This question was asked in the NEET 2017. This question was asked in the NEET 2017. Have a look into this question. The question is saying that, have a look at this question. The question is saying that, suppose the charge of proton and electron differ slightly. Suppose the charge of proton and electron differ slightly. One of them is minus E, the other is plus E, right? Okay. If the net electrostatic force and gravitational force between two hydrogen atoms placed at a distance is d apart is 0, then what will be the delta d is delta E is an order of, given mass is this is this. So they are trying to compare the gravitational force and the electrostatic force. Now you know that there are two masses, doesn't matter what is the amount of this mass, there will be gravitational force between them, right? And the gravitational force will be Gm1 m2 by r square, Gm1 m2 by r square, right? This is the gravitational force. And if these are charges, right, the value of electrostatic force will be k times q1 q2 by r square. My dear kids, the m1 m2 and r, value of g you already know, 6.67 10 to the power negative 11. Value of k you also know, 9 to the power 9. Q1, Q2 is given, R square is given, R square and R square you can cancel out as well. Now when you take the ratio of these two things, you will find that the ratio comes out in the category of, the ratio comes out in the category of 10 to the power minus 7 in that order, right? So see that the gravitational forces are so small as compared to the electrostatic forces between the particles, right? You see that the gravitational forces are so small as compared to the electrostatic forces acting on the particle. Now look at that. This is the NEET 2017 question, right? The diagrams are shown like this. So over here, all the lines are parallel to each other. This is the 10 volt line. This is the 30 volt line. Here you see that there is a slight variation. Here you see that there is a slight gap in this one. And the last one, the situation is like this. Now you have to talk about the positive charge is moved from A to B in all these cases. The positive charge is moving from A to B in all these cases, right? Now the positive charge is moving from A to B in all these cases. So what will happen? What statement is true? In all four cases, the work done is same. Maximum work is required in the fourth figure, right? Maximum work is required in the second figure. Maximum work is required in the third figure. So we have to talk about that. My dear kids, work done to move a charged particle. My dear kids, the value of potential difference is work done per unit charge to move the point across those 2 points where you are calculating the potential difference. So work done to move a charge between the point A and B, if the potential difference between A and B is V, so the work done will be potential difference between the points into the charged particle, okay? If point A and point B has potential difference V and you are moving a charged particle Q across them, then how much work you have to put in? V into Q, right? Listen again. If there are 2 points A and B and they have a potential difference V across them, you are moving a charged particle Q across those 2 points, then the work done will be V into Q, all right? Work done will be V into Q, all right? Okay, so what is really happening? between these 2 points, what is really happening? The charge particle Q is moved. The charge particle Q is moved across them. The charge particle Q is moved across them. This is 10 volt, this is 30 volt, this is 10 volt, this is 30 volt, this is 20, this is 40. So over here, the potential between 10 and 30, the potential difference is 20 volt. Between 10 and 30, the potential difference again is 20 volt. Between 20 and 40, the potential difference is 20 volt. Between 10 volt and 30 volt, the potential difference is 20 volt. So you see that when the charge particle is moving from A to B, you are always moving across 2 points with the potential difference of 20 volt. Yes or no? When the charge particle is moving from A to B, you are always moving between 2 points with a potential difference of 20 volt. And if you are always moving between 2 points with a potential difference of same value of 20 volt, we can say that the work done will be 20 into the same charge. We can say 20Q, 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 20Q is the amount of work done across all of them. So we can say that the amount of work done will be same across all of them. So in all 4 cases, the work done is same. In all 4 cases, the work done is same. I hope the idea is very, very clear. All right. So let's move on and talk about the next numerical. Alright, so the next question is this: the electric field in a certain region is acting radially outward and is given by E is equals to A into R. Electric field in a certain region is A into R. Alright, that is how you are giving it. This is the magnitude of electric field you are giving it in that region. A charge contained in a sphere of radius A is centered at that region at the origin of the sphere. So in this region, a charge Q is centered. A charge is contained in a sphere of radius A. The radius of this sphere is A. All right. And the origin, what will be the field? Okay, of the field will be given by the electric field in a center region is acting radially outward, and it is given by E is equals to A into R. It is given by, field is given by E is equals to A into R. A charge contained in a sphere A centered at the origin of the field will be given by. Okay, so how much charge is going to be there at the center? Let's say that at the center of this particular region, the available charge is Q. We have to find that what is the value of that available charge. We have to find that what will be the value of that available charge. Okay. All right. So my dear kids, here we can think in terms of the Gauss's law, right? We can think in the terms of Gauss's law, right? Think about it. The value of electric field varies as a linear relation with the distance from the center. So, right, what will be the electric field on the edges, right? So, you see that at distance equals to the radius, the available electric field magnitude is going to be A into the distance, right? A. Small a is the radius of that sphere. So the electric field over here on the edges will be E into A, right? The electric field over here is going to be E into A, right? Now, from the Gauss's law, you can say that the net flux is simply charged enclosed upon epsilon naught. Here you have to find out in this region how much charge is enclosed. This value of Q you have to figure out. Right, this value of charge you have to figure out, yes or no, right? Okay, and how much flux is associated? How much flux is associated with the entire surface? We can say that flux on the entire surface is E into, what is flux? E into the total surface area, yes or no? What is total flux on the surface? What is the total flux on surface? We can say that E into total surface area, that is charged inside upon epsilon naught. This is something you have to figure out, right? So over here you can write it, charged inside is going to be E into area into epsilon naught, right? What is the electric field? Electric field at the surface is A into A, right? A into A. What is the area? 4 pi R square, which is A square epsilon naught. Multiply all of them. 4 pi small a cube capital A epsilon naught. This is the final value, right? 4 pi, or you can write in this way, 4 pi epsilon naught A cube into A, which is the option A, right? 4 pi epsilon naught A cube into A, which is the final option, right? Option A is the correct option, right? Option A is the correct option. Very good. Gani Kolar, absolutely correct. Ananya, absolutely correct. Ayushi, absolutely correct, right? Very good. All these kids are giving the absolutely correct answer, right? Now let's move on and talk about one more question. This is asked in 2014, right? So we have almost covered last 10 years of questions from the chapter of electrostatics. Like most, we can say that good questions we have covered in the last 10 years. So conducting a sphere of radius r is given a charge q. The electric potential at the electric field, electric potential and the electric field at the center of the sphere will be, right? So a conducting sphere of radius r is given a charge q, right? A conducting sphere, the sphere is conducting, so all the charge will automatically come on the surface. So all the charges are available only on the surfaces, right? Because it is a conducting sphere, right? This sphere has a radius r and the available charge is q. The electric potential and the electric field at the center of the sphere. So what will be the electric potential over here, V, and what will be the electric field over here, right? What will be the electric potential and electric field at the center of the sphere, respectively r. So electric potential over here is kq by r, right? Kq by r. So k is 1/4 epsilon naught q by r, and electric field over here is 0. In fact, at every point inside the surface, this particular shell, it is going to be 0. In this conductor, it's going to be 0. So option B is going to be the correct answer, right? Option B is going to be the correct answer. I hope that it is very, very clear. All right, very simple. Option B is correct. KQ by R and this. Yes or no? Let's move on and talk about another question. Right. A charge is placed at the center of the line joining. As the charge is placed at the center of the line joining, the two equal charges. There are two equal charges, Q and Q. Okay. And a small charge Q is placed between them. Okay. At the center of that. So it is placed at the center of these two things. Okay. The system of three charges will be in equilibrium at what value of a small charge Q? So we want this three charge system to be under equilibrium. We want this three charge system to be under equilibrium. It is only possible when it is experiencing the same amount of force in both the direction, either this way or the other way. So basically it has to be in equilibrium only when this small charge is going to be in equilibrium when it is experiencing same amount of force in both the direction. If it is a positive charge, it's a positive charge, and this is also a positive charge, then in which condition we are stopping this one, we are stopping this one. So the third one will be under equilibrium when it is repulsed by this one and it is under repulsion by this one, and both of the repulsion are same, right? These forces must be cancelled out on each other. So it is also possible that between these two things, what is the force? K times Q1 Q2 by R square, right? Placed at the center of the line joining these things. Okay. R square. This is the value of force which will be acting in between these two things, right? And if I add it up with another force, we can say what will happen? The value of the net force will be 0. Yes or no? KQ square by this thing is going to be 0. Okay, one second. Okay. So there is a small thing. We have to read this part as well. This cannot be positive charges. Understand that. There is a small line written in the question. We want the system. The system of three charges will be in equilibrium, right? We want the system of these three charges to be in equilibrium, right? Think about it. In which condition the system will be under equilibrium? Think about it. For the system of the charges to be in equilibrium, every pair has to be under equilibrium as well, right? Every pair has to be under equilibrium as well. Yes or no? Right. Every pair has to be under equilibrium as well. Okay. All right. In this way, this is the charge particle. This is another charge particle Q. This is the charge particle. These are Q and this is Q. For these three things to be under equilibrium, we can say that the forces on each other must be cancelled out, right? So forces on them must be balanced by the forces on these two, right? Okay. So now think about it. Let's call it A. Let's call this charge B. Let's call this charge C, right? So we can say that force on A and B, FAB, and if you add it up with force on A and C in a vector manner, right, the net force has to be 0. Then only the system will be under equilibrium, right? If we want the system to be under equilibrium, we can say that if you add up the net force between any two things, that should cancel out with each other, right? So that is the case. Now, between these two things, the net force, if you are calling this as x and this is also as x, so the total distance between A and B is 2x. The value of force is going to be K times Q1. This is capital Q, this is capital Q. K times Q square, capital Q square upon 2x square. right, which is 4x square, basically 2x ka whole square, right? And force between A and C is K times Q1 Q2, Q into small q upon x square, and you add it up and that should be 0, right? This is how the thing is. The net force here, the net force here is 0. So over here, F between A and B is this K times Q square, Q1 Q2 by 2x square, right, which is 4x square coming out like this way, right? And that should be equals to the force between these two things, which is K times Q1 Q2 by x square. So that should cancel out, and once you do that, the small q can be figured out as q by 4, right, which is your answer. All right, now let's talk about the next idea. Okay, let's talk about the next idea, right? The next idea is from the chapter of current electricity. The next idea is from the chapter of current electricity, right? Okay. All right. All right. Okay, so now look at the first question of the current electricity and try to solve it, right? And as I said, okay, at this moment you can drop, if you are not already good enough in solving the circuit based problem and potentiometer problems, right, you can drop them, because if 2 or 3 questions will be asked from this chapter, only one question is likely to be from that circuit solving part, and for that you can invest days and still not master that particular portion, right? Here I have collected many questions from the previous year that do not require the circuit solving part, but still they are all from the previous year papers, right? They are all from the previous year papers, right? So let's go ahead and solve the questions. This is from the previous year, NEET 2025. Okay, read it. A wire of resistance R is cut into 8 equal pieces. A wire of resistance R is cut into 8 equal pieces, 8 equal pieces, right? And then from these pieces, 2 equivalent resistances are made by adding 4 wires together in parallel. So out of these 8 pieces, 4 wires are added in parallel like this, and 4 wires are added in parallel like this, right? Then these two sets are added in series. These two sets are added in series, okay? The net effective resistance of the combination is going to be, so what will be the net effective resistance of this thing? Very simple question, right? Only anyone who can think just the basic stuff can solve it. You see that the wire has a resistance rho L upon A, so the resistance of the wire is directly proportional to the length, right? If you reduce the length to half, the resistance is also reduced to half. Here we are reducing the length to 1/8. So every portion has a resistance of 1/8 of previous value, right? So every portion has a resistance R by 8, R by 8, R by 8. My dear kids, you know that if two resistances are added in parallel, the net resistance is 1 upon R1 plus 1 upon R2. And if those resistances are same, so the net resistance is 1 upon R plus 1 upon R. And if 3 same resistances are added, so 1 upon R plus 1 upon R plus 1 upon R. If 4 resistances are added, 1 upon R plus 1 upon R plus 1 upon R, one more time. And if n resistances are added, then this much. Now think about it, 1 upon R is 2 upon R, again 1 upon R, 3 upon R, again 1 upon R, 4 upon R, and so on n times. So the net resistance is n upon R, right? So we know that the net resistance will be R upon n, all right? So clearly, if 2 resistances are added in parallel, the net resistance will be R upon 2. If 3 resistances each having the value R are added in parallel, the net resistance will be R upon 3. If 4 resistances each having the value R are added in parallel, the net resistance will be R upon 4, just like that, right? So here we have 4 resistances each having the value R by 8. They are added in parallel. The net resistance of this combination will be R upon n. So for one part, the resistance is R upon 8, and there are 4 such parts, so R upon n. That will be the net resistance of this portion, right? So we can say that R upon 32 is the net combination resistance of the first portion. Similarly, R upon 32 will be the net combination of the next 4 set. They are added in series, so you are going to add them up. This and this are added up. So 2 times R upon 32, which is R upon 16, which is option A, right? I hope the idea is very, very clear. Okay. Any confusion? Option A is clear. Ananya, very good. Manjulika beta, I believe you have done a mistake, and now it is very clear that where have you done the mistake, right? So yes, Ananya has given the right answer. So I hope the idea is very, very clear. Y R upon 16. Clear hai? Y R upon 16 is the correct answer. Is that clear? Okay. Now, let's move on and talk about the next question. It is asked in the NEET 2024, right? The question is saying that a uniform metal wire of length L has a 10 ohm resistance. A uniform metal wire of length L has a 10 ohm resistance. Now this wire is stretched. Okay, to a length of 2L, right? This wire is having a length L, okay? Now when you are going to stretch it, the wire will get thinner, okay? Now the length is 2L. This one has a resistance 10 ohm, right? Then after stretching it to 2L, it is also bent into a perfect circle. This wire is bent into a perfect circle. Okay, right? The equivalent resistance across any arbitrary diameter of that circle will be, right? The equivalent resistance across any arbitrary diameter. So if you take any arbitrary diameter like this, how much of the portion you are going to cut? My dear kids, if the total length is, if the total length is 2L, the total length of this thing is 2L, right? And you know that if the diameter is D, the radius is R, we can say that for this, the circumference is going to be 2 pi R. Yes or no? So the radius of the circle being formed, right, is R, then the 2 pi R is the total circumference, which is equal to this 2L, right? Which is equals to 2L, right? You are going to take this length and make a circle out of it. So total circumference is the length of this thing, right? Okay. So the radius is L upon 2 pi in case we are going to need it. So we know that, right? Radius of this thing is L upon 2 pi, all right? Radius of this thing is L upon 2 pi. My dear kids, think about it. Across any diameter, right? When we go about and talk about across any diameter, right? Think about it. The equivalent resistance depends on how much length you are going to capture, right? The equivalent resistance depends on how much length you are going to capture, right? And if you think basically, you can easily calculate the final value, right? Think about it for a minute. I have given you enough hints, right? That part, by the way, was not required, but anyways, I have done it. So think about it. If you go for any random diameter, what will be the thing? The equivalent resistance across any diameter. Right? I'll give you one more hint over here. If you like try to solve it, okay, like the derivation of that part I have done in the main classes as well. I can give you the hint of the derivation. When you stretch the wire, what remains same? The volume remains same. Volume is cross sectional area into length, that remains same. So basically what happens when you make the length n times, the resistance of the wire definitely increases. It increases by n square times, right? This is a simple identity, right? When you equate the volume and derive that what is the new resistance and calculate that, you will find it the new resistance after stretching is n square times the previous resistance. You are stretching it by 2 times, so it is 2 square times previous resistance. If you stretch it by 3 times, it is 3 square by the previous resistance. So it is something you can do. Previous resistance was 10 ohm, so it is 4 into 10, it is 40 ohm, right? Now, when you go for any diameter, my dear kid, so what is really happening? Across any diameter, so that part was not really required, so I can rub it. Okay, so you see that what is really happening? So this perfect circle, this circle is perfect because the question is saying so. Across any diameter, when you're going to calculate the equivalent resistance, basically what you are doing, think about it. This is a wire, right? And you are talking about any 2 points across the diameter, right? So basically, 2 points across the diameter will divide the entire wire into 2 parts, right? One part above these 2 points, right? And one part below these 2 points. And think about it. How are these two wires, these two resistances connected? Are they in series or are they in parallel across these 2 points A and B? Any 2 points across a randomly chosen diameter will divide the circle in 2 parts, the part above and the part below. And both the parts are in parallel with one another, right? And if you think of that, it is basically a parallel combination, right? The total wire has resistance of 40 ohm, right? Here you've seen that. Total wire after stretching has a resistance of 40 ohm. So upper half has a resistance 20 ohm and lower half has a resistance 20 ohm. So basically 20 ohm and 20 ohm are connected in parallel with one another like this. Yes or no? All right. And if two resistances are connected in parallel with one another, the net resistance will be 1 upon R1 plus 1 upon R2. So 1 upon 20 plus 1 upon 20. All right. So it is going to be 2 upon 20. All right. So the net resistance is going to be 10 ohms. All right. The net resistance is going to be 10 ohms across any 2 points randomly chosen across diameters, right? So I hope the idea is very, very clear. The net resistance is going to be 10 ohms, right? Very good numerical. Look into this question. It was asked in the year 2023, right? The question is saying that a certain wire A has a resistance of 81 ohm. Certain wire A has a resistance of 81 ohm. The resistance of another wire B of same material and equal length but of diameter thrice of the diameter of A will be. Okay, so the certain wire A has a resistance of 81 ohm. Resistance of this wire is 81 ohm. The resistance of another wire B of same material and equal length, but the diameter is thrice of A, right? So you see that length is same, but the diameter is thrice of A, right? What will be the resistance of this thing? What will be the resistance of this thing? Again, think about it. Okay. So resistance is rho L upon A, right? Length is same, material is same. They are telling us. So resistance depends on area in the inverse proportionality. That means R1 upon R2, it will be A2 upon A1, right? Previous resistance is 81. The new resistance you don't know, it is R2, right? A2 is the cross-sectional area, which is, you can say that it is pi d square by 4. Okay, d2 square by 4. And here it is pi d1 square by 4. So this part can be cancelled out. So it is d2 by d1 ka whole square. My dear kid, the diameter before after is 3 times the diameter before. So d2 by d1 is 3. All right. So 81 upon R2 is 3 times, which is 9, right? So R2 is going to be 9 ohms. I hope the idea is very, very clear. The net new resistance is going to be 9 ohms. The new resistance is going to be 9 ohms. I hope the idea is very, very clear, right? Option B is correct. Very good. Very good, Rushikesh. Very good, Ananya. Very good, Manjulika. Option B is correct. Very good. Anushka, good try. But option B is the correct option, right? Now let's talk about the next one. It is asked again in the NEET 2023, right? NEET 2023. Focus. A copper wire of radius 1 mm. It contains 10 to the power 22 free electron. A copper wire of radius 1 mm contains how many free electrons? The number of free electron is 10 to the power 22 free electrons per cubic meter, right? That many free electrons per cubic meter. All right. The drift velocity for free electrons when 10 ampere current flows through the wire will be. What will be the drift velocity of free electron when the current flowing through the wire is 10 ampere? It is given that the charge of a single electron is 1.6 into 10 to the power negative 19 coulomb. It was not needed, right? So what will be the value of drift velocity? My dear kids, the drift velocity is NEAVD. Okay, so this is the charge of one electron. So it was not needed because kids generally remember that, right? So this is the amount of charge on a single electron, E. So if this is something you know, I is equals to NEAVD, right? I is equals to NEAVD. If the drift velocity is Vd, then the current flowing is going to be NEA/Vd. So from here, the drift velocity will be I upon NEA. My dear kids, cross-sectional area can be figured out because the radius is given, right? Radius of the cross-section is given 1 mm. So pi r square, do that. R is going to be 1 in 10 to the power minus 3 meters, right? And that will give you the value of cross-sectional area, right? E is something that is given 1.10 to the power negative 19, and number of the free electrons are also given 10 to the power 22, right? So all these values are given to you. The drift velocity you have to figure out. Again, a direct formula based question was asked in the NEET 2023, right? Direct formula based question was asked in the NEET 2023. Rushikesh, I forgot to ask the question, but gave you poll. Next time I will give you the poll. Look at this question. The reciprocal of resistance is, again, 30-second poll is there. You can answer it. The reciprocal of resistance is conductance, reactance, mobility, conductivity. What is the reciprocal of resistance? What is the reciprocal of resistance? What is the reciprocal of resistance? Conductance, resistance, mobility, conductivity. Answer it. So reciprocal of resistance is called as conductance, right? Option A should be the correct option, right? Option A is the correct option. So yeah, everybody is giving the correct answer, and Ananya is the fastest one. So let's have a look at the next one. It was asked in the NEET 2022. Again, you see that there are a lot of simple questions that they are asked. A cell of EMF 4 volt and internal resistance 0.5 is connected with a external resistance of 7.5 ohm external resistance. The terminal potential difference will be, so you see that the EMF of the cell is 4 volt, the internal resistance of the cell is 0.5 volt. It is connected to the 7.5 ohm external resistance. It is connected to the 7.5 ohm external resistance, right? The terminal potential of the terminal potential difference will be the, what will be the terminal potential difference? V. What will be the terminal potential difference? V. Right? Think about it. So you can say that if this is how the cell is, this is the internal resistance, and here we have the external resistance. So the terminal resistance, basically potential difference we have to talk about. The terminal potential difference for the cell we have to talk about. Terminal potential difference, right? The effective potential difference that will actually come out of the circuit, right? Okay. So think about it. When the current is flowing through this circuit, apply the Kirchhoff law, or whatever you, if you remember the values directly, V minus IR equals to the net potential difference across this thing, right? I into R, right? So try and apply it. Good evening, Beta Surya. All right, so those kids who can solve it, definitely should try to give the answer right now. You have your 30 seconds, but those who cannot solve it, I'm giving you some hints over here, right? So the circuit is like this. So we have a circuit. This is the battery. You can also imagine it in a much easier way like this. This is the circuit. This is the internal resistance, right? So this is the battery. This is the internal resistance of the battery, right? And here you are connecting the external resistance with it, okay? All right. So the current I is flowing in this particular loop. You can apply the Kirchhoff law, and you can directly tell that V minus IR minus I capital R, that will be 0. Yes or no? Across this, if you apply it, right, that you can start from here and you can move it in this way. So V minus IR, I capital R minus I small r, that is going to be 0. I hope that is very, very clear. So what will be the value of current? Here you can take the current common. So value of current will be V upon R plus R. Yes or no? This is how much current is going to flow across this one. Now the terminal voltage across this thing is the voltage across the external resistance, right? So what will be the voltage across the external resistance AB, right? We can say current through it V equals to I, and to the external resistance R, right? Current through it is this V upon R plus R. This is the net current, and the resistance is a capital R, right? So just put all the values. The applied potential, the value of the value is of EMF is 4 volt. The value of V or E is 4 volt, right? And R plus R, 0.5 plus 7.5, right? And external resistance is again 7.5. So just multiply it and you'll get the value, right? Okay. So I hope the idea is very, very clear. Just multiply it and you'll get the value. Ananya is saying option B, just multiply it and you will get the value, right? Whatever value you are getting is the final answer. 3.75. Okay. All right. So let's move on and talk about the next one. It is again asked in the NEET 2022, right? Two resistors of resistance 100 and 200. Two resistors of resistance 100 and 200. R1 is 100. R2 is 200. Are connected in parallel in an electrical circuit. The ratio of the thermal energy developed is 100 ohm. In 100 ohm to that in 200 ohm will be. So my dear kids, both of the resistors are connected in parallel, right? And now what is going to happen? Both of the resistors are going to be, they are connected in parallel, right? And the current, whatever current is coming, will be divided into two parts, right? So you see that the lower resistance will get more current and the higher resistance will get lesser current. So because of which it is heated to some amount, it is also heated to some amount. The ratio of thermal energy developed in both of them is going to be, what will be the ratio of thermal energy developed in both of them? All right. Think about it. Can I say that the potential difference across both of them will be same because they are connected in parallel? So potential difference across this is V, potential difference across this is V. You know that the heat generated per unit time or the power consumed per unit time, heat generated per unit time or power consumed per unit time across resistor is or rate of heat generation is basically V by R square, right? V by R square, yes or no? Oh, sorry, V square by R, right? V is equals to IR, right? From here, P equals to VI, right? So you can just replace the current from here, V by R, multiply current in place of current, put V by R, so it is V square by R, right? So the amount of heat energy produced per second is V square by R. Why are we calculating it in terms of potential? Because across both of them the potential is same, right? So now if you try to take the ratio of H1 and H2, it is V square upon R1 and V square upon R2. Potential is same across both of them, so this is cancelled out. So it will be R2 by R1, right? 200 by 100, which is 2. 2 is to 1, right? So the amount of heat produced is going to be in the ratio of 2 is to 1, right? Clearly you can get with the common sense that the lower resistance will get most of the current, and because of which it will be heated more. So the ratio of heat generated per unit time is 2 is to 1, right? Look at this numerical. It was asked in the year NEET 2021, right? It was asked in the year NEET 2021, right? Look at this question and try to answer it. The effective resistance of a parallel combination, the effective resistance of a parallel connection that consists of 4 wires of equal length, equal cross-sectional area. Right, effective resistance of parallel connection that consists of 4 wires of equal length, 4 wires of equal length, equal cross-sectional area and same material is 0.25 ohm. What will be the effective resistance if they are connected in series? What will be the effective resistance if they are connected in series? My dear kids, if 4 equal wires of resistance are connected in parallel, right? Meanwhile, you can solve it and try to answer it in the comment section, right? If 4 equal resistance each of R are connected in parallel, right, parallel, then what will be the net resistance? We can say that R upon 4, okay, individual resistance upon 4, and right now it is coming out to be 0.2425 ohm, right. So clearly individual resistance is 4 times this, which is 1 ohm, okay. So when you connect 1 ohm resistance, 4 1 ohm resistance in parallel, then the net resistance will be 1 upon 4 like this, right. And over here what is going to happen, right, over here what is going to happen, so once you calculated that this is going to be the net resistance over here, we can say that after this they are connected in series now, right, they are connected in series now, right. So R, 1 ohm, 1 ohm, 1 ohm, 1 ohm, they are connected in series, so the net resistance will be 4 ohm, right. So option A is going to be the correct option. Option A is going to be the correct option. Yes, Ananya beta, very good, right. Option A is going to be the correct option, right. Let's move on and talk about the next one. Some kid is saying D. They are not asking one of the resistance. We are saying that all 4 resistors are added in parallel, series after that. What is the net resistance once they added in series, right? That is what we have to answer, right? What will be the effective resistance if they are connected in series? This is something we have to answer, right? Now let's move on and talk about the next one. This question is asked in the NEET 2019. Which of the following acts as a circuit protection device? Circuit protection device. Directly answer karo usko. Answer it directly in 30 seconds. Right. Inductor, conductor, switch or fuse. Inductor, conductor, switch or fuse. What is the purpose of circuit protector? Which one of them will act as a circuit protector? Which of the following will act like a circuit protector? Very good. It is the fuse, right? Fuse acts as a circuit protector because it will destroy itself by heating it up. If the current is too much, fuse will simply be utilized, right? And it will protect the circuit by doing so. Now let's move on and talk about the next part. The next question is asked in the year 2016. It is saying that the filament bulb has 500 watt and 100 volt, right? 500 watt, 100 volt is to be used in a 230 volt main supply. When a resistance R is connected in the series, it works perfectly and the bulb consumes 500 watts. What will be the value of R? What will be the value of R, right? The filament has, the power consumption of 500 watts, right? And 500 watt at 100 volt, all right? So when you're supplying 100 volt, it consumes 500 watt, right? So you see that in this particular situation, you can easily calculate one more thing about the bulb, because power consumption is V square by R, right? In terms of potential and resistance, it is this. So here you have it, 100 square upon resistance, we don't know, and the power consumption is 500. So from here, you can easily calculate the resistance of this thing, 20 ohms, right? So resistance of this particular bulb is nothing but 20 ohms, right? Now what is happening? When a resistance R is connected in series, it works perfectly and the bulb consumes 500 watt again. What will be the value of R? Now we are connected in 230 volts instead of 100. So what will happen, right? What will happen? Right. So clearly you see that after you are removing the bulb from a 100 volt supply and now you are connecting the bulb in 230 volt supply. But the idea is when a resistance R is also connected in series with it, right? So you have this bulb of 20 ohm and along with this bulb, a resistance R is connected with it. And now this thing consumes 500 watt again. So we have to talk about what is the value of this R, right? We have to talk about what will be the value of R, right? Now, we know that now the new power consumption is, because we have to talk about in the series, the same thing that is there is current, right? So the new power is V into I, right? The new power that you should be using is V into I, V square by R is the same formula, V into I, because the current here is going to be same, right? The current here is going to be same, right? Okay. Now, how much current is going to be there? Because the power consumption is 500, right? And the voltage is 230. So from here, the current can be calculated, like how much current will be flowing in the circuit, right? How much current will be calculated in the circuit in this situation? When a resistance, one second, when a resistance R is connected in series, it works perfectly, and the bulb consumes 500 watt. What is the value of R, right? Just a second. Filament bulb is 500 watt and 100 volt. It is to be used in 230 volt main supply. When a resistance R is connected in series, okay, it works perfectly, okay, and the bulb consumes 500 watts. Perfect. The value of R is going to be, all right. So it is, initially we are not removing it from the 100 watt supply, right? We are still in the 100 volt supply, right? So power is equals to V into I, right? So power is basically 500, voltage is still 100 and I. So current right now is 5 ampere. When it is across 100 volt supply, the current it is going to consume along with this resistor is 5 ampere. You see that? When it is in 100 volt supply, the current it is consuming is 5 ampere, right? And we want it to consume that, right? We want it to consume that. Now you see that if you want a bulb to work in a new environment, what do we want? We don't want the current to exceed beyond a certain value, because the filament of the bulb is designed for a certain value of current, right? So in the previous circuit, when it was connected in a 100 volt supply, how much current was flowing through it, right? When it was consuming 500 volt power and all, 500 watt power and all, how much current was flowing through it? It is designed for 5 ampere current, okay? Now, if you are connecting at a higher potential difference, if the current crosses that 5 ampere, the filament will break and it will not work perfectly, yes or no? So now, in a newer circuit, what do you want? In a newer circuit, what will happen? We wanted to design in such a way, right, that it is for the old situation. Let me write it separately. This is for the old situation, right, when there was 100 volt of power supply across the 100 volt of power supply across the bulb, right? This is the bulb and you have 100 volt power supply across it. So you see that when the 100 volt power supply was there, it used to consume 5 ampere current, right? So when the 5 ampere current is flowing, this bulb was working perfectly. It is designed for 5 ampere. If you increase that 100 volt to 230, it will not be able to sustain that. So that now we wanted to protect. So basically the potential difference is rising. So to protect it, we have added a additional resistance. Now I believe it is more clear, right? To protect it, we are adding a new resistance along with the bulb, right? Because we are increasing the potential difference from 100 to 230. I hope the idea is better right now, right? Previously it was 100. Now we are making it 230. You see that for this bulb to work right now, we can say that another resistance has to be added so that this filament will not break. Yes or no? Okay. Now, how much of the power is taken up by this particular part? Right. We can say that. What is the potential difference across this resistance in this situation? Right. Across this one, we are still providing 100 volt, right? Because the bulb is designed in such a way that it works perfectly in 100 volt. So the other resistance must take away all the additional potential difference. So basically, the other resistance has 130 volt, right? That's the easiest way of understanding that particular part, right? So what is the voltage across the resistance? Is current across the resistance into the resistance itself, right? Okay. So the voltage across resistance must be 130 volt so that the bulb can continue efficiently. The value of current is 5 ampere and the resistance we don't know, right? Now the resistance will be 130 by 5. Okay. It is 26 ohms. So 26 ohm is the answer, right? So let me explain it one more time, right? The question is good. It's a slightly good question, right? We can say that. It was asked in the year 2016 and it was a slightly good question, right? You see, we have a bulb, right? And the bulb is designed to consume 500 watt when it is operating across 100 volt, right? So when the bulb is at a potential difference of 100 volts, certain current is flowing through it, right? and the bulb is designed for that values of current. If you increase the potential difference, then what will happen? If you increase the potential difference across the resistance or across the bulb, the current will also increase. Ohm's law, V is proportional to I. But increase the potential difference, the current will also increase, right? And the bulb is not designed for that additional current, right? The bulb is designed for P is equals to V into I. Bulb is consuming 500 watt. When the voltage is 100 volt, that means the current is 5 ampere. The bulb is designed for 5 amperes of current, right? So to protect the bulb for higher potential difference circuit, we have to add additional resistance, which is what we have done. So for the 230 volt that you are applying, 100 is still there on the bulb because it is working perfectly right now. And now rest of the additional potential difference must be there on the resistance, right? We want to find out what is the net value of resistance. So we can say that the current through the entire thing must be 5 ampere, right? And since the current is 5 ampere, just like the previous case, the bulb is still growing just as bright. So for that, V is equals to IR. For this one, the potential difference is 130. The total was 230. Across this one is 100. So across the remaining one is 130. So 130 is 5 into R. R is going to be 130 by 5, which is 26. I believe the idea is very, very clear and the question is crystal clear with everybody, right? Is there anyone who has any confusion with this question? Is there anyone who has any confusion with this question? Question clear hai sabko? All right. And answer is also very, very clear. Let's move on and talk about the next one, right? Let's move on and talk about the next one. Understood. Very good. Okay. So the charge flowing through the resistance R varies with the time t following this equation. AT minus BT square. Right. The charge flowing through the resistance R varies with the time t as this equation. The charge is varying with time, right? Where A and B are positive constants. What will be the total heat produced in across that resistance? What will be the total heat produced across that resistance? Now think about it, right? These are the options you have: AQ bar upon 2B, AQ bar upon B, AQ bar upon 6B, AQ bar upon 3B, right? These are the options you have, right? I'll not disturb you for, let's say, a minute. It's a very good question and it will teach you a lot of things, right? This question was asked again in NEET 2016. In NEET 2016, just 10 years back, the question paper was relatively, you can say that, challenging, right? Okay. Think about it. You know the value of charge, right? So what is current? Current is rate of flow of charge, right? What is current? Rate of flow of charge. So by differentiating it with respect to time, you should be able to get the value of current. Okay. By differentiating it with respect to time, you should be able to get the value of current. Okay. So for those kids who can solve it, directly go ahead and start solving it. For those who cannot, we can directly learn it over here. So you see that to get the value of current, we have to differentiate both sides, dq by dt. Rate of flow of charge is what? The value of current. Okay. Now differentiate t to the power 1. Differentiation is nx to the power n minus 1, which is 1 only. 2t square, differentiation will be 2t. So 2b into t, right? This is how the expression will be. So the expression for current is a minus 2b into t, right? The current itself is changing with time, right? The current itself is changing with time. Yes or no? Right. So now I hope the idea is very, very clear. So we have to talk about what will be the total heat produced in the resistance. What will be the total heat produced in the resistance? My dear kids, the value of current you can write over here, a minus 2bt. Okay. Heat produced is I square RT. Yes or no? My dear kids, from here we can write this expression in the time dt. The amount of heat produced is going to be dH. It is going to be this I square R dt, right? Now, when the time changes from 0 to t, the heat produced will be, the total heat produced will be H, let us say. So just integrate the whole thing. The value of I is this, 0 to t, a minus 2b into t squared, right? And the R is there into dt, right? The resistance of this thing is constant, so it will come out of this integration sign. Here a minus b ka whole square, a square plus b square plus 2ab you can apply and integrate it after that, right? So integration of a square will be a square into t. Integration of this 4b square t square will be 4b cube by 3, and then integration of 2 times a into integration of 2 with ab will be similarly done, right? And now after that you have to put the limits, right? These are the limits for the current. These are the limits of the current, right? So you need to know that what will be the values of current. You see that the current at the total heat produced, yeah, so the value of current at t is equals to 0 will be a minus 2b into 0, which is a, right? Okay. And at what value of time the current will be 0? At what value of time the current will be 0? Let's say that put the value of current is equals to 0. So a minus 2b into t. So t will be a upon 2b, right? So at this value of time the current will be 0. At this value of time the current will be 0. I hope it is very, very clear, right? All right. The total heat produced in this thing is going to be integration of this thing. So just integrate it and you will have your answer. So upon integration of this thing, we are integrating from 0 to this value of time, right? This is the total time when the current gets 0. So initially from the beginning till this time when the currents get 0, right? So total heat produced you have to find out, my dear kids, right? Total heat produced you have to find out. Think about it. In this wire, initially from t is equals to 0, right? Till the time current flows, right? Time is till the time current flows. That means eventually the current will become 0. From right now, when the current is flow has some value, till the current becomes 0, some heat will be produced. So how long will it take for the current to become 0? We can say that for the current to be 0, the value of time is a upon 2b. So from t is equals to 0 till t is equals to a upon 2b. This is the total time duration for which the current is flowing. At a upon 2b, you can say that the current becomes 0, right? This is the final time. So in this duration, the current flows through the wire. So these will be the limits of this thing, right? So t is equals to what? Final limit of the time is a upon 2b, right? And that's how you can integrate it and get the final answer. Got it? How did you get the limits? My dear kids, listen it one more time. Here, this is the wire. This wire is carrying the current, right? The current itself is changing with time, right? And the value of current is a minus 2b into t, right? If you put t is equals to 0, the current is equals to a units, right? Now, initially there was some value of current, right? But you see that the value of current will reduce with every single value of time. And when you put the I is equals to 0, you will find that t is equals to a upon 2b. That means at a upon 2b, the current will be 0, right? Initially the current was something, and at a upon 2b, the current is 0. So in this window of time, in this duration from some current to no current, right? Some current is actually flowing through the wire, right? And what will be the total heat produced due to that blip of current, okay? So we are talking about that from initial time to the final value of time, which is a upon 2b, till the last current was there, right? You can integrate it between these values of time and get the final answer. Is that clear? Right. The entire struggle was about the limits of time, okay? Now again, this was again, I have picked many questions from 2016 paper because it was very good, right? So those people who want to challenge themselves, right, they can pick the question paper from 2016, right? So the question is this: a filament bulb of 500 watt 100 volt is used in 230 volt supply. Similar question, right? Similar question in another set it was asked, right? Look at this question. A circuit contains an emitter, a battery of 30 volt and a resistance, right? A circuit contains an emitter, a battery of 30 volts and a resistance 40.8 ohm, all connected in series, right? Battery of 30 volt, resistance is this, 40.8 ohm, and they are all connected in series. If the emitter has a coil of resistance 480 ohm, the emitter has a coil resistance of 480 ohm and the shunt of 20 ohm, right? The shunt resistance of ammeter is 20 ohm. The reading in the ammeter will be, right? What will be the reading in the ammeter? If the ammeter coil has a resistance 480 and the shunt of 20 ohm, what will be the reading in the ammeter? Think about it, right? Think for a minute. Okay. Think for a minute for this particular question. Okay. So the situation is like this. We have a 30-volt supply, all right? We have a 30-volt supply like this, right? And from this 30-volt supply, we are connecting a resistance in the circuit like this, 40.8 ohm, and an ammeter is also there. So we are trying to split up the ammeter. Ammeter has a resistance, a coil resistance and a shunt resistance. So let's show them separately. But the whole thing is just one unit, one ammeter, right? So this is the ammeter. This is the coil of ammeter. This has a resistance of 480 ohms and a shunt, that is a parallel resistance to it. It has a value of 20 ohms, right? So now this is the situation you have in front of you. What will be the reading in the ammeter? What will be the reading in the ammeter? Think about it. So when 480 ohm and 20 ohm are connected in parallel, so due to that, what is the effective resistance of the ammeter? What is the effective resistance of ammeter itself? We can say R1 R2 upon R1 plus R2. So 20 into 480 upon 20 plus 480, right? So this is going to be the effective resistance of the ammeter itself, right? Now, whatever that value comes out, let's say 20 volt, 20 ohm, whatever net value of resistance comes out, that is in series with the 40 ohm, 40.8 ohm resistance, right? This resistance is in series with this resistance. Let's say this is 20, this is 40. So effective resistance is 60 ohm, right? Effective resistance is 60 ohm. 60 ohm of net resistance is there in the circuit. Now, how much current will be drawn from the power source? We can say that the current drawn will be 30 upon net resistance of the circuit. 40 plus 20 is 60. So 30 upon total resistance 60 ohm will give you the final answer. I hope the idea is very, very clear, right? Very good, Ananya beta, right? So over here, the net resistance of ammeter, kitna aaya Ananya? Ammeter ka resistance kitna aaya? What is the value of resistance of this ammeter itself, right? It was somewhere around 20. I solved it before the class. So it was something around 20, right? So 20 plus 40 is 60 and just divide 30 by 60. So around 0.5, right? Okay. So that's it, right? So 0.5 is the correct answer. Okay. 0.5 is the correct answer. Option C is the correct option. Okay. All right. So now two metal wires of identical diameters are there. We have two metal wires of identical diameters, right? And identical dimensions, they are connected in series. If sigma 1 and sigma 2 are the conductivity of the combination, then what will be the final relation between them, right? Sigma 1 and sigma 2 are the conductivity of the combination, then what will be the final answer, right? What will be the relation between the conductivities? Okay. Conductivity of the combinations, conductivity of the combination. So think about it. Two metal wires of identical dimension. Let's say that this is the first metal wire, right? and we are connecting another identical wire in series with it. So both of them have same length, same cross sectional area, right? Both of them have same cross sectional area and same length. All right. This one has conductivity sigma 1, this one has conductivity sigma 2, right? And now what we are doing, we are adding them up, right? Okay. Now conductivity is sigma 1. So what will be the resistance of the first part? We can say the cross sectional area is A. So it is 1 upon sigma 1 into A, right? Or the net conductivity, you can add it up, 1 upon sigma 1 into A and 1 upon sigma 2 into A, right? Yes or no? Rho L upon A. So you know that the resistance is nothing but rho L upon A, right? Okay. Resistance is rho L upon A. Let's start from here. This is a better way of understanding, I believe, right? Resistance of any wire is rho L upon A, and over here, what is rho? Rho is called as resistivity. What is rho? Rho is called as resistivity, right? 1 upon rho is called as conductivity, right? This is a better way of looking at these things. So sigma is what? Conductivity. Now the same expression for resistance in terms of conductivity will be L rho. In place of rho, if we can put 1 upon rho is sigma, so we can say that we can invert it. We can put sigma into A. Think about it. 1 upon sigma is nothing but rho, right? So both the expressions are same. 1 upon sigma is nothing but rho. So this expression is resistance in terms of resistivity. This expression is resistance in terms of conductivity. Both are same things, right? Now they are added in series. So what will be the value of net resistance? What will be the value of net resistance? We can say the net resistance will be 1 upon R1 plus 1 upon R2. Let's solve it in this way. This is easier, right? What is the resistance of the first portion? What will be the resistance of the first portion? We can say resistance of the first portion will be rho L upon A. We are writing in terms of conductivity. So it is L upon sigma A. So R1 is L upon sigma A, right? L upon sigma A, like this, right? Okay. Or we don't have to do even that, right? Because the conductivity is there. So we can 1 upon resistance is basically we can directly add up the conductivity. So the net conductivity we can add up directly. Yes or no? Right. The net conductivity we can add up directly. Okay. We can say that, let's say for equivalent length, let's say that L equivalent upon sigma, for the net thing, sigma equivalent is this and area is this. This is going to be L1 upon sigma 1 A1 plus L2 upon sigma 2 A2, right? Why do all these? 1 upon R, basically we have done the same stuff. We just reversed it, right? We have done the same stuff, right? So basically what is really happening, cross sectional area is same everywhere, right? Now the effective length right now is twice of this total length, 2L, right? So we can just add it up. We can just add it up, right? So this is 2L upon equivalent sigma L1 upon sigma 1 plus L2 upon sigma 2, right? So L1 is nothing but L, L2 is nothing but L. This can be cancelled out. So you see that 2 upon equivalent conductivity is 1 upon sigma 1 plus 1 upon sigma 2. So you see that it is sigma 1 plus sigma 2 upon sigma 1 sigma 2 is 2 upon equivalent this thing. So you see that sigma equivalent will be 2 sigma 1 sigma 2 upon sigma 1 plus sigma 2. Simple expression, right? 2 sigma 1 sigma 2 upon sigma 1 plus sigma 2. This is going to be the simple expression, right? So option C is the correct option in this particular part, right? Option C is the correct option in this specific part, right? That's it. That's pretty much everything about this particular session, right? And now I'll say that Keep on solving few more questions from your own end, right? And when you keep on doing that, right, when you keep on working on those fronts, you will definitely see that what are the areas where you need to work more, and what are the areas that we can say that we can avoid doing right now because the time is very limited. Okay, so if you do all these things, right, you will see that gradually your subject will give you the confidence, right, that you need at these particular moments, right? Now, various times, as you have seen, while solving, right, we can come across a better way of solving a question, right? So you can drop a traditional way while in the main exam, because your ultimate aim is to how to get the answer much quicker, right? So if you get an approach like to explain it, I have to tell you multiple things, I have to go through like how do we get the formula and explain all these things, but you don't have to do all that, right? You can start directly talking about these 4 lines and get the solution and done, right? So this is the difference between how you should solve and how we have to tell that, right? My dear kids, all the best for your upcoming exam, and keep on trying and keep on working on your goals. All right, take care, bye bye.